Okay, so today we're going to talk about Blackboard assignment number 4, which is your Lesson 1 notes for Unit 6 on rational equations and functions. So Lesson 1 is really going to focus on graphing simple rational functions. So to start, you have a video warm-up. Hopefully you've had a couple minutes to go through numbers 1, 2, and 3. The answers are given to you for all 3 of those problems. The next time that we meet in class, we will go over these questions that you may have about this warm-up. But for right now, we're going to move on to graphing simple rational functions and the notes that you guys are going to take for Blackboard assignment number 4. So to start out, a rational function is a function of the form f of x, so we have a function here, is equal to some function we're going to call p of x over some function we're going to call q of x. And those are going to be polynomials, with q of x obviously not being able to equal 0. So we're going to look at the parent functions of these rational functions, and the parent functions are actually given on your note sheet. And here you have the two graphs, y is equal to 1 over x and y is equal to negative 1 over x. And if you notice, they obviously have similarities, but they also have some differences. Of those similarities, you notice that these two graphs have what are called branches. We're going to talk about that in just a couple minutes. Y is equal to 1 over x looks like this, where you have two branches that are in quadrants 1 and quadrant 3. And then obviously you have y is equal to negative 1 over x. And you've got your two branches that look very similar to what they look like in the first graph, but you have your branches that are in quadrants 2 and quadrants 4. The important piece is to know what these graphs are called, and they're both called hyperbolas. So your graph of your rational functions are going to give you the graph of, your graphs are going to look like what we call hyperbolas. So if you flip it over to the second sheet, your graphs are given to you again up at the top so that we can talk about them as we go through the properties. So these both are called hyperbolas, and again, if you notice, y is equal to 1 over x gives you your two hyperbola branches in quadrants 1 and 3. And y is equal to negative 1 over x gives you your hyperbola branches in quadrants 2 and 4. So let's talk about some properties of these rational function graphs. The first is, properties that are always going to hold true, is your x-axis. So your x-axis is the horizontal asymptote of these two parent functions. So your two parent functions, your x-axis is your horizontal asymptote. And if you remember, horizontal asymptote, your horizontal line is kind of like your horizon. It runs from left to right. And it basically means your asymptote that nothing is going to pass or cross over that line. So your graph of your hyperbolas or your rational function, your graphs, are not going to cross over your x-axis. This is your horizontal asymptote. Your y-axis of these parent functions is going to be called your vertical asymptote. And your vertical asymptote, again, is your vertical line where your graph does not cross. So in other words, your horizontal asymptote is going to be the line y equals 0. And your vertical asymptote is going to be your line x is equal to 0. A couple more pieces of information of these parent functions. The domain of your function, and again, your domain deals with all of your x, I'll put that down, your x variables, your inputs, and your range, which deals with your outputs, or y, are all non-zero real numbers. Non-zero real numbers. Another property is your graphs have two symmetrical parts, and we called them branches already, and that's what they're called. They're going to be symmetrical, which means that they would lay right on top of each other if they were to be folded over. In this case, if we had your 45-degree line, your negative slope, if you folded those two branches over, they would lay on top of each other. If I took this line, your positive 45-degree angle that cuts through your coordinate plane, and folded those two branches over on top of each other, those two would also be symmetrical. They would lay right on top of each other. And the last piece of information, your properties of your hyperbolas, is the last bullet point. So for each point xy on one branch of y equals 1 over x, so this is obviously talking about the first graph, then you know that the point negative x, negative y is going to be part of your other branch. Okay? So those are 5 bullet points properties that are going to hold true for your hyperbola graphs. So let's talk about example 1. In example 1, they're giving you a graph of a rational function. And in this graph, there's a couple things that you're going to want to notice. The first is this looks very similar to the parent functions that we talked about before. So y equals negative 4 over x. We want to find and state the domain and range for each of these, and I gave you guys 3 steps to follow through with example 1. So in the first example, the first thing that we're going to do is we're going to locate and draw our asymptotes. So since this looks very similar to the parent function of our second graph, the y equals negative 1 over x, there's not a lot of translations going on here. We know that our asymptotes are as follows. Our vertical asymptote is going to be our x equals 0 line, and our horizontal asymptote we know is going to be our y equals 0 line. If you kind of are confused as to x equals 0, y equals 0, vertical asymptote we can call our y-axis, and our horizontal asymptote we can call our x-axis. That's okay to plot for right now. So I'm just going to graph those axes, or highlight them on our graph off to the right. There's our horizontal asymptote and our vertical asymptote. So as we start drawing and plotting this graph, we know that our branches that we're going to get from this rational function, it is not going to be able to cross our asymptotes. So starting out, step 2, we want to plot a few points. So I'm going to take my original function, negative 4 over x, and I know that to plot a few points, I want to pick x values that when I plug into this original equation, I get nice numbers back out. So since I'm dividing by x, my numerator's a negative 4, I'm going to pick nice numbers that work with 4 so that when I divide, I get nice numbers back. So I'm going to actually start off with 1. Negative 4 divided by 1 gives me negative 4. So I know that that's going to be 1 point on my graph. Because I know that point is going to be on my graph, because of my 5th bullet point of my properties, I also know that the opposite point is also going to be on one of the branches. So if I flip both of those signs, I also know that the point negative 1, positive 4 is also going to be part of my graph. They're opposite in symbols. Another number that works good with dividing by 4 is 2. So if I take 2, negative 4 divided by 2 gives me negative 2. I also know the other point, negative 2, positive 2, is going to be on my graph. I'm going to do one more point. It's always nice to have at least 3 points when you're graphing. So I'm going to pick another point. So another number that works well with dividing by 4 is itself, which is 4. So negative 4 divided by 4 gives me negative 1. So I also know the point negative 4, positive 1 is going to be on my graph. So now that I have 3 made points per branch, which really gives me 6 points, I can go ahead and plot those points on my graph off to the right. So if I do that, I get 1, negative 4, 1, 2, 3, 4. If I get negative 1, positive 4, 1, 2, 3, 4, 2 over, 2 down, 2 to the left, 2 up, and then 4 over, 1 down, 4 over to the left, 1 up. And if I connect those points, remind yourself that you can't cross your asymptotes. I'm going to get a graph that is going to be very similar in how my original graph, the y equals -1 over x, looks above. So because my numerator, my -4 up top, is negative, I know I should have branches in quadrants 2 and 4. And because it's negative and it matches what my graph should look like, I know that there's a really good chance that that is correct. So last but not least, we need to look at step number 3, and not step number 3, but step number 4, which actually should be number 4. We have to list our domain and range for example 1. So our domain is what values for x, again your domain is all your inputs, your range is all your outputs. So what values for x am I allowed to have in this function? So if I look left and right along my x-axis, I know that I can, when I have positive x values, I have a graph that correlates with it. If I go to negative x values, I have a graph that correlates with it. But what I don't have is an x value for 0. Because remember, x is equal to 0 is a vertical asymptote. So because of this, I know that x can never equal 0. Because that is an x value that is not part of my graph. If I look at my range, which is now all my outputs, my y values, if I look at my y-axis, if I go up, I have a graph that coordinates with my positive y values. I also have a graph that coordinates with my negative y values, but what my graph never hits is y is equal to 0, because that is, of course, my horizontal asymptote. So y cannot ever equal 0 in this graph. A couple quick things I want to point out before we move on to the next couple examples is whatever your asymptotes are equal to, okay, whatever your vertical and horizontal asymptotes are equal to, I want you to think about how that relates to your domain and range, and we'll talk about that the next time we get together in class. There is a relationship between your asymptotes and what your domain and range will include. Okay, so moving forward, a couple key pieces of information that may be worth noting. So for the functions of the form y is equal to a over x, so obviously a being any number that we choose, so an example is y is equal to 2 over x. This is very close to our parent function other than the fact that 1 is not up top, so we can have another value other than 1 up top. So the value of a tells you the shape of your graph. So if a is greater than 0, so we're going to go along with y is equal to 2 over x. If a is greater than 0, so it's positive here, the branches of your hyperbola will always be in your first